Well, good afternoon, everyone. Welcome to our second to last seminar of this academic year. My name is Caitlin Motes, and I am the IT project manager over in IT for UW-Tacoma. This is our computer literacy seminars in conjunction with the Center for Data Science. Today, our topic is Introduction to Cloud Computing, and it's going to be taught to us by Jaslyn Cower, who is one of our fantastic literacy seminar students. And she is also a Master of Science student in the computer science program here at UW-Tacoma. So she'll be talking about that today, and I'll turn it over to you, Jaslyn.
Thank you for the introduction. So let's begin with the seminar. So today's topic is Introduction to Cloud Computing. So without any further ado, let's discuss what is actually cloud computing. Cloud computing is the on-demand delivery of IT resources over the internet with pay-as-you-go pricing. Instead of buying, owning, and maintaining physical data centers and servers, you can access technology services and such as computing power, storage, databases, and needed on basis. So there are multiple cloud providers like Amazon Web Services, IBM Cloud, and Google Cloud Platform. So let's talk about what the main characteristics of cloud computing are. So we'll talk about these 5 main characteristics: that it is an on-demand service. It is available all the time, 24/7. It offers resource smoothing. It offers rapid elasticity, and it's a measured service. So let's talk about the first characteristic of cloud computing, which is an on-demand self-service. It means that anyone who is using a cloud provider does not need to worry about provisioning of the resources. The cloud computing resources does not require any human administrators or any human intervention. So they can monitor and manage the computing resources as they need it. The next cloud characteristic is the broad network access. So it means that cloud services are widely accessible and they are 24/7 available. So AWS offers, I think, more than 20 regions where they support cloud services. So they are widely accessible, they are global. And cloud computing services are generally provided over standard networks and heterogeneous devices, which again offers a huge availability and offers the user a 24/7 hour availability. The next characteristic is multi-tenancy and resource pooling. So think of it like this: you are living in a household, and there is a landlord, and you are the tenant. It means we are using the resources of the landlord. Similarly, in cloud characteristics, one of the cloud characteristics is multi-tenancy and resource pooling. It means that multiple cloud providers can pool their resources together and share them with multiple users. For example, if you see this is a single tenant model. It means that there is one landlord and you are renting their space and you're living in their house. That means you share all the resources with that particular landlord. And the second one is the multi-tenant model. It means that resources are multiplexed and shared amongst multiple users. So the multi-tenant model, which is multiplexed, it offers a better isolation. For example, if there is a cloud service customer A and there is a cloud service A, they have a separate database that they interact with. And on the other hand, if there is a cloud service customer B who is accessing resources of cloud service B, then there will be a separate database to handle the services of that particular cloud customer. Are there any questions to know? Okay. So moving on, the next cloud characteristic is elasticity. So you know that a rubber band which is used to tie your hair, it is elastic, right? If you stretch it, it will adapt as per the size. And if you leave it, it will go back and shrink to that particular size. Similarly, with the cloud, there is an enhanced elasticity. So there is an automated ability of cloud to transparently scale resources. For example, if I want to host my front end or back end on a server, and there are multiple client requests coming in. To handle these requests, our cloud resources will scale up automatically. The cloud computing resources should have services should have IT resources that are able to scale out and in quickly and as a need basis. It means that if a request limit has reached and a single particular server cannot handle multiple requests, we'll automatically either either enhance the size of the server or add multiple servers to our cloud. So whenever the user requires services, it is provided to them, and it can scale out and scale in as per the requirement. And the next cloud characteristic is that cloud computing is a measured service. So any service that you used is measured for billing purposes as well as for the automated scaling purposes. So cloud platform tracks the usage of IT resources for billing purposes. Secondly, it enables charging for IT resources only for the amount of service that is used, and it is measured in terms of milliseconds, seconds, hours, or delay. For example, if you used a particular storage service, for example, AWS S3, if you use it for an hour, you will only be billed for that particular hour and not more and not less. Next, not all measurements are for billing. Some measurements can also support auto scaling. As we talked about in the previous characteristic, that was elasticity. That while we are using the resources, they are measured for that particular amount. If a request limit has reached above the measurement, then the cloud resources can automatically scale up or scale down. Hence, the cloud characteristic is that the cloud is a measured service. So these were all about the characteristics. Are there any questions till now? Okay, so let's talk about cloud delivery models. So think of it as a triangle. On the base level of the triangle, we have infrastructure as service. The middle part of the triangle is platform as a service, and the upper part is a software as a service. So if we talk about the bottom level, it is basically used by IT administrators, and the flow of control goes from below to above. It means that the IT administrator infrastructure has as a service, the users who are using it have more control to the services of the cloud, and the flow of control reduces when it reaches the end users, that is the software as a service. So talking about the first model, which is infrastructure as a service. So as in the former definition, I said that users need to worry about provisioning. Similarly, in infrastructure as a service, the users who are using need to worry about how the foundation of the cloud is built. So infrastructure as a service allows you to create and manage virtual pre-configured machines. You can also deploy compute power in less time without complexity. It means that you have been offered a virtual machine and you really don't know where it is. You really don't know how it's managed, but you are given a provision, you are given an authorization to use those machines. For example, AWS offers Elastic Compute Cloud or EC2 instances. So these are the virtual machines that the IaaS packages like this look after the storage and networking of these particular virtual machines. And all you need to do is simply launch it. You just need to configure it. You need to tell them how many CPU cores it may utilize and other computing power of that particular machines. And you don't need to worry about where the power is coming from or where it is located or how it is managed. So you can basically maintain the database security components and its applications, and really not need to worry about how it is functioning. The next cloud computing delivery model is platform as a service. So this is basically used by software developers, and it lets you write and test code, all without worrying about managing the system that you're working on. So developers particularly like PaaS for this reason. It just lets them get on developing without need to worry about where the IDE is present, or how I should write the code. So past products also involve building of APIs and offering features that allow us to write APIs. It also helps to split our traffic and monitor the version control of the systems. For example, the Amazon Web Services, they offer API gateways. So you can configure API gateways with your functions, and on triggering them, um, you can uh, you can just trigger them as an end user and not need to worry about where it's actually built and how the internal working of the API is, or how the proxy works, or how the load balancer works in splitting the traffic. The next model that was on the top of the pyramid was the software as a service. So software as a service is used by end users. SaaS apps allows you to make use of tools, and you don't need to worry about fixing or maintaining them. For example, Gmail, Dropbox, Netflix, Salesforce, all these are examples of SaaS applications, even Google Drive. So all the storage or the computational heavy lifting happens on the cloud, and you can access the proofs of these labels over the internet via a browser based interface. So you don't need to worry about the backend functionality as an end user. You just use the products and interact with those products. So this was all about the cloud delivery models. So when Kobe asked you to pick up Legos, you may be confused, like why what are we building? What is actually happening? So let me now disclose it. So with the Lego examples that using a Lego example, I'll demonstrate what Docker is and what containerization is. For example, like you picked up a couple of Legos from Kobe, and you really want to build a cool castle, which looks like this. So currently, like you and me, both of us want to build a castle with the same, but our pieces are mixed up. You don't have a plan, right? So you won't be able to build a castle that you want. However, if I give you this particular set of Legos to play with, yeah. Using this, you can use your own creation, and so basically you can use these Legos and you can work with them independently, and you can build your own castle. You can move the flag around and use it to build your own castle. So Docker is like having separate boxes for each of your Lego projects. It lets people who build computer programs keep their projects organized and not interfere with each other. For example, this is the Lego. This is the Legos that I'm using to build a castle, and you are using your own Legos to build a castle. So our Legos are not interacting with each other, and we are not interfering with one another's work, and we can independently build our own castle. So this is what a Docker is. Second, what is a Docker image? It is like a set of instructions to build your own castle. Now that we're talking about castle, if we look at this one has a green flag and this one has a purple flag. So in the instruction file, I'll write that I want to build a castle with the purple flag. So this is basically the need of the Docker image, that it lets you write a set of instructions to build a Lego castle. So you can hand over the instructions to your friend and ask them to use it to exactly to build the exact same castle with the purple flag on the top. Next, we've talked about containerization, like what Docker is. Second, what is a Docker image? But how do these work? So to make them work, there's a concept of Docker container. So Docker containers are running instances of the image. So a Docker container is like the actual Lego castle that you build. It's a real working thing that you can use and play with. You can create many castles, Docker container using the same set of instructions, Docker image, with the help of the independent Lego pieces that are Docker, Docker given to you in a box. So let's move on to the formal definition to make the concept even more clear. Adoption is a platform that makes it easy to create, deploy, and run applications in an isolated environment called containers. It helps developers to package and distribute software consistently, avoiding any issues caused by different system configurations. For example, if I have this set of castle and my friend also has the same castle, then there will be no mix-up and we can work in isolation. Next one is the Docker image. Docker image is lightweight, standalone, executable package that includes everything needed to run a piece of software, including the code, runtime libraries, and other dependencies. Images are created from the set of instructions called Docker file. So how did I create this Docker image? How did I create this particular piece? I was given a set of instructions in my in the Lego instructions. I was given a set of instructions to on how to create a Docker file. So this is particularly a Docker image, and the Docker container is a running instance of the Docker image. Containers are isolated from each other, and the host system allows you to run multiple applications simultaneously without conflicts. Like without any conflicts, me and my friend can work with these Docker containers. They can play with these classes independently. So these containers can be started, stopped, or restarted easily, and make it simply to manage and deploy the applications. So are there any questions till now about anything about the theoretical part of cloud computing and what exactly a Docker image is?
I don't really understand what Docker is. So is it the entire box?
Yeah, so basically it's a box that you can help to basically it's a box that you can play around, and it offers a set of instructions on how to build your code exactly. So to make it more clear, I can show you a demo, and we can take this question later if it's still unclear. So let's move on to the demo. Yeah. So this is the virtual environment that I'm doing. So everything I'm demonstrating here will be in the Linux environment. So I've created a project CLS demo, and it has these particular files: app.py, Docker file, requirements.txt, and this is a bash script that I will be using. So let's go through one by one. So for example, this is app.py that you want to host on the cloud. This is a Python file that you want to host on the cloud, and everyone and the users want to access the files without worrying about where the file is placed and how it is provisioned. So if I see what is there in app.py, so it's simply a function that returns hello from Lambda container. Next one is a Docker file. So this is a set of instructions on how to build a Docker image. So you don't need to worry about what exactly it is being coded to. It is just a set of instructions that will tell you that okay, these are the libraries that needs to be installed, and app.py is the file that needs to be copied, and basically this would be your endpoint from where app.py is run. And this is the requirements library. Like I don't need any library right now, so my requirements file is empty. So so what a Docker will do is that it will build that image. So Docker is an isolation environment wherein your particular app.py file will be placed, as well as the supporting libraries will be placed. So it offers an isolation environment which will be hosted on the cloud.
So it's like your virtual box, but it's called something else.
Yeah, like
Like
a setup, just like a box that is hosted on a virtual machine. So it's just a set of instructions, like a file or anything. Probably it can be a website as well as its supporting library. It can be a simple HTML page, CSS content, and any library that is needed to run that particular file. So next, what I do is I just run a script. So in this script, what I'm doing is that if there are any, I'm just, you can see this part, it is just for a clean starter. Next is I ran a command that is, I ran a command that is used to build a Docker image. So I can also show you what exactly is in that Docker extension. So basically, it would firstly perform the cleanup, like if there are any Docker images, running instances of Docker images on my machine, it can just simply clean it. And then this command, sudo docker build it basically builds my Docker image. So all the building happens in there. If you see that load Docker ignore all the context that are all the instructions that are being implemented one by one. So this is how a Docker image is being built, and it is being built via the same Docker file that was used where the set of instructions was written. Again, if you go back to the Lego example, there was a set of instructions on how to build a castle. Similarly, a Docker file is a set of instructions on how to build a Docker image. So so basically, this is the image that you copy all the requirements, then you install all the libraries, and then you copy all the Python files that are needed. And this will create an independent isolation model for execution. For example, this is the Hello World Docker image, and it contains the app.py and supporting libraries. Next is to host the Docker image. AWS offers multiple services to do that. So in order to not make any more complicated, we can skip this part that I'm just posting my Docker image on a particular repository like GitHub. If I'm pushing my code, I push my code on GitHub, right? Have you used GitHub before? I have. Yeah. So, so you know the interface. So, when I push my code, I do like I forgot the command. I think it was commit message, and then you push it to the repository that and the branch that you wanted to do that. Similarly, I want to push my branch to a repository on AWS. So I'll create a repository and I'll push the repository. So again, like if I do sudo Docker images, it will display all the Docker images that are currently present in my machine. So I hope this part is clear about the Docker. Next, like we were talking about hosting our code on GitHub. Similarly, our Docker code is hosted on the Elastic Container Registry. So this is the repository that is being created, and this is the Docker image that is based on the repository. So now let's talk about how to trigger this Docker image, how to run the Docker image. It's only just like it's only a set of classes, but you can't use it right now. It's just there, but you can't play with it. So let's learn how to play with it as well. So AWS offers various Lambda functions, and let's create a function that will use the Docker image that was placed in my repository. So I'll click on the container image. I'll add a function name. I'll choose the repository. I'll choose that particular image, and I'll create my function. So my function has been successfully created. Now let's test the function. So I clicked on this test button and I can see the execution logs. And if I go to the details, the output from that app.py is being displayed. So basically, you packaged that app.py in the Docker and you packaged all the supporting libraries. And this packaging, after the packaging, it will be called a Docker image. Now that Docker image goes to a repository. If you do like git push, similarly, Docker push to an ECR repository. And in order to run the image, in order to see how it's working, so we created a Lambda function and we tested the Lambda function, and the output of the Lambda function would be the contents of the app.py. So I hope was it clear?
I had a different expectation, like on your console, we saw the only hello from Lambda container, not the full body.
Yeah. Because this is the return. This is what's returning from the app.py. If you do it right, so it basically calls this function.
Okay.
It will call this function, and what is being returned from the function would be the output of the function. And how does the Lambda function know like how to call it? So if you go to the Docker file, we put a set of instructions like in this Docker image, all the requirements will be copied, requirements will be installed, the app.py will be copied, and the entry point will be app.handler. It means that it will trigger it will invoke the handler function, and after invoking it, this piece of code will be returned. Okay. And again, like this is a set of instructions on how to create a Docker image. And this is the Docker image that we push to our repository. Okay. Are there any questions on Zoom?
Doesn't seem like it.
Okay. All right. So this was about it. So thank you so much for attending.
All right, fantastic. Thank you, everybody. And we'll be doing one more seminar before the end of this academic quarter. And that will be on May 24th, same time, same place. We're not quite sure who that speaker is going to be just yet, but very excited for everybody to join us. So we'll see you then.